A volcano erupts under the sea, the shockwave circles the Earth twice, and then something happens that absolutely no one saw coming. The eruption changes the climate of the entire planet.
Today we're going to take a very close look at this, so let's get started right away.
What I'm showing you today has blown researchers worldwide away. A volcanic eruption that shook the atmosphere so violently that it inadvertently reduced one of the planet's most potent greenhouse gases.
And the craziest thing, it's only now, with the help of satellites, that we've understood what really happened back then.
But let's start from the beginning. The date is January 15, 2022. In the South Pacific, about 65 kilometers north of the Tonga archipelago, lies an underwater volcano named Hunga Tonga-Hunga Ha'apai, situated below sea level. On this day, it erupted with a force rarely seen in recorded history. The explosion is so massive that the resulting shockwave circles the entire globe multiple times and is even measurable at weather stations in Europe. The ash cloud shoots up into the mesosphere to heights of up to 55 kilometers. Normal airplanes fly at altitudes of about 10 to 12 kilometers. The eruption of Mount Pinatubo in the Philippines, one of the strongest of the 20th century, reached a height of just 40 kilometers. Hunga Tonga significantly surpassed that. On top of that, there is something that makes this eruption physically unique.
Because the volcano is located under the sea, it hurled enormous amounts of water vapor directly into the stratosphere during the eruption.
An estimated 146 million tons of water ended up there. That corresponds to roughly 10% of the total stratospheric water supply. By the way, if you want my subscriber numbers to skyrocket in a similar way, please feel free to follow the channel now. Thank you so much everyone for your support. Along with the water, the following were catapulted upward. Volcanic ash, sulfur compounds, and salts from the ocean, a veritable chemical cocktail high above our heads. And now comes the part that left the researchers in awe. When scientists led by Dr. Martin van Herpen from the company Acacia Impact Innovation analyzed satellite data from the European Tropomi instrument, they discovered a compound in the ash cloud that shouldn't actually be there.
Formaldehyde. And in quantities that have never before been measured in the stratosphere.
Up to 12 molecules per billion air molecules at an altitude of 30 kilometers. That sounds like a small amount, but in this context, it's record-breaking. All previous measurements were below 0.1 molecules per billion air molecules. Why is formaldehyde so interesting?
Formaldehyde is a short-lived intermediate product in the breakdown of methane. When methane is decomposed in the atmosphere, formaldehyde is temporarily produced in the process,
before it breaks down further into CO2 and water. Formaldehyde has a lifespan of only a few hours. It is then destroyed by sunlight, so if it is found in the stratosphere over the course of days, it cannot simply originate from the eruption itself. It must be continuously produced anew. This means that something in the volcanic cloud has been actively breaking down methane, and has been doing so for days, and this finding could change everything. Dr. van Herpen describes his surprise at the new findings regarding the volcanic eruption as follows. When we analyzed the satellite images, we saw a cloud with a record high concentration of formaldehyde. We were able to track it for 10 days all the way to South America. Since formaldehyde only exists for a few hours, this showed that the cloud must have been continuously breaking down methane for more than a week.
But how does it work? The key lies in a chain of reactions that at first sounds like a chemical fluke.
The seawater that the volcano propelled upward contained salts, including sodium chloride, in other words, ordinary table salt. In the stratosphere, these salts encountered volcanic iron particles in the ash, and when sunlight strikes this combination of iron and chlorine, something remarkable occurs. Free chlorine atoms.
And chlorine is an extremely efficient methane destroyer. A single chlorine atom can break down methane in a chain reaction. The researchers calculated that at its peak, the volcanic cloud broke down around 900 tons of methane per day. That sounds like a lot, but on a global scale, it's actually a relatively small amount. But the crucial point is something else. The fact that it could be measured at all is the real scientific breakthrough. And these findings could be very important.
After all, methane is the most significant human-caused greenhouse gas after CO2. Over a 20-year period, it has 80 times the climate impact of CO2. And while we've been debating the CO2 curve for decades, methane has actually gained momentum recently. In 2020 and 2021, atmospheric methane concentrations rose faster than they have in 40 years. The sources are diverse. cattle farming, rice paddies, landfills, wetlands, and fossil fuels. But the good news is that methane breaks down on its own in the atmosphere within about 10 years. This fundamentally distinguishes it from CO2, which accumulates over decades.
So, anyone who reduces methane emissions or actively removes methane from the air will see the effects relatively quickly. Some researchers therefore refer to targeted methane reduction as a kind of emergency brake for climate change. It's a measure with a rapid effect, whereas with CO2 you would have to wait decades.
The phenomenon observed at Hunga Tonga was already known to some extent, though in a completely different context. In 2023, researchers discovered that Saharan dust blowing across the Atlantic mixes with sea salt, releasing chlorine atoms that then break down methane. This mechanism takes place in the lower atmosphere, the troposphere. The fact that something similar could now also happen in the stratosphere was simply not on anyone's radar,
in the truest sense of the word. Professor Matthew Johnson from the University of Copenhagen, who was involved in both discoveries, sums it up perfectly.
What is new and completely surprising is that the same mechanism apparently occurs in a volcanic cloud high up in the stratosphere, where the physical conditions are completely different. And this is precisely where an exciting research prospect opens up, because if nature carries out this process on its own, could we mimic it artificially? Could we intentionally introduce iron chloride particles into the atmosphere to actively break down methane? Could we elevate ourselves to masters of Earth's climate and control it as we please? The idea sounds tempting, but it is still some way from implementation. What side effects would such an intervention have? What would that mean for the ozone layer, for other trace gases? All of that is still open to question, but at least we now know how we would detect the whole thing. That is how we could measure whether such an intervention had worked. Dr. Joos de Laat of the Royal Netherlands Meteorological Institute, one of the study's co-authors, describes the actual achievement of the work as follows. How do you prove that methane has been removed from the atmosphere? How do you know the method works? That's very difficult, but here we show that methane depletion can indeed be observed using satellites. So what's the bottom line? An underwater volcano in the South Pacific has almost accidentally shown us that the atmosphere has mechanisms we don't yet fully understand, and that there may be ways to harness these mechanisms to counteract climate change. Is that realistic? Is it safe?
All of this is still unresolved, but the first step has been taken. Now we know how it would be measured, and in science that's often the most crucial step of all.
If you want to stay up to date on further developments, be sure to subscribe to the channel now. Feel free to give it a thumbs up too, and speaking of scientific breakthroughs, something is happening in space right now that's sending astronomers into a frenzy. Something very strange is happening in our solar system, and researchers are faced with a mystery that's shaking up existing physical models. You can find out what's going on, why our solar system is behaving contrary to the laws of nature, and what that means for us in the video shown in the top right corner. In the bottom left, you can go to the shop and stock up on everything a nerd's heart desires. Otherwise, I'd say see you in the next video. Take care, everyone.